Hello and welcome to the 11th video making simple Floppy Robin using Cocos2d for JavaScript. So in the last video we simulated the spawning of the tubes. What we're actually going to do in this video is get them on the screen. And to do this I've actually pre-prepared the code because there's a little bit to type and with my typing speed it's going to take forever. So apologies for that if you prefer it when it's typed out, but it's available for download and I'd rather just explain how it's going to work because it's the last little complicated point. You'll need to create tube.js inside the JavaScript, the JS folder here, and remember also inside Hello World to add the reference to the file here. Tube.js is an extension of CC Sprite, just as Robin.js and Cloud Sprite were, so in Cloud.js, and it's very similar to the Cloud Sprite, just with some little differences and tweaks, and that's what I want to explain now. So we have some properties here. We have the screen width, the speed, pixels per second, something called x offset, just like the cloud, whether it's been scored or not, an inactive x, and a tube state inactive. If you remember in Game Manager we've set the offset x at 100 and the inactive x at -1000, and then we've got the two states here. So how does a tube work then? Well, first of all we initialize some of its variables, which I'll come back to in a minute, and then when we need a tube, we either create a new one or find an inactive one, start it moving, and then when it reaches whatever destination it should have done, it gets stopped, and this stop positions it in a certain way, ready to be reused again. So it's easier to explain exactly what's going on using this diagram here. So if I look at this as a whole, what we have here is the blue area is the screen and the orange is a tube. So when a tube is first created, it's set to inactive x, so an x position of -1000, so way off the left of the screen, and sits there waiting until we need to use it. And when we do, it gets set to a position of the screen width plus offset x, which is 100. Gets told it's going to move a distance of the screen width plus offset x again to arrive here, like so, with offset x like this. And then when it's reached this position here, it'll then be set as inactive and moved to sit at -1000, ready to be reused again. To do this movement all the way across the screen here, we'll use its speed to calculate the time it should go. And the other thing to know is at some point the Robin may collide with a tube, or this one indeed, and at this point we'll want the tubes to freeze for that little delay we put in the last video, but when we re-enable after game over, then we want the tube to be set here. And this is where a couple of the differences are between this and the normal cloud sprite. So back to the code, how's that done? Well, the first thing we do is once we've created the tube, we call an initialize function to set up the inactive x, the x offset speed and width. We set the various parameters in here, which should be fairly clear now, including the position, the x and the y of the tube. It's at a y0 and an inactive x, set as inactive. And then where all the good stuff happens is when we actually call start. So when we need a tube, we then call start on it. So the first thing we do is stop any other actions. There shouldn't be any, but in case there are, we'll call stop all actions. We calculate the distance, which remember is 2 lots of offset x plus the screen width. Calculate the time, dividing the distance by the speed, and the destination, which is just off the x offset off the left-hand side of the screen, and this is y. So again, just to recap, it's put here with offset x, so screen width plus 100. The distance it needs to go is 1 offset x, 1 screen width, another offset x, and the sorry, I've got myself mixed up there. That's here. Yes, of course, the destination it arrives then is minus offset x effectively, because x is 0 on the left hand side of the screen. And then when it reaches there, it needs to be dumped here. So we do that here, then we set its current position just off the right hand side of the screen at offset x, set it to active, set it to visible, and then we put a move action on to move across the screen to the destination in the time defined, and then when it's finished that, we'll call reach destination, just like we did with the move action here, with the cloud like this, and the reach destination here. The reach destination then calls the stop function, and the stop function then stops all the actions, makes the tube invisible, sets it to inactive, and then sets it way off the left hand side of the screen here, ready to be used again, and sets the fact it's been scored to false. We'll see how that works in a later video when we do the scoring. So that should be relatively clear. Any questions, just drop me a comment, but I don't think there's anything new in there at all. What we can do now then is go into game.js, and in game.js we want to make an array of tubes just below the array of clouds, and now we can actually get into the programming part of the tubes. You remember that we left it last time here where we spawn either an upper or a lower, or we spawn a tube pair. What we want to do now is add in some more functions to actually do that. And the first we want to do is add in a function to actually spawn a new tube. And again, I'm going to paste this in. You can download this to make things a little bit quicker. So we want to get the tube. This function will be declared shortly. And then we will need to know if it's an upper type, set the anchor point at 0 for the y, which means, whoops, wrong app. Here we want the y position to be based at the 0 here. Or we want to set the anchor point at 1 in this case here. Then we need to flip the y depending on whether it's an upper or a lower, so we've got the right y position for the right end of the tube. And then we're ready to set the tube's y and call the start function on the tube for its scrolling across the screen. The only other thing remaining is how we're going to get the actual next tube, and this is why we have a tube with a state, so that we can reuse anything that's waiting rather than always creating new sprites. So when we call getNextOne, the first thing we'll do is loop through all of our tubes. If we've got one that's inactive, then we'll just return that one. That one will then be returned to here as a tube. We'll set the y position and call start and setting it moving across the screen. Otherwise what we need to do is create a new tube from the tube image. We need to initialize this tube, so we'll set it with the speed of a tree. We'll set its offset and inactive as we have in Game Manager, and the size.width. And in fact, one thing is these are all constants here, but I've put them in like this because you can add many more features and things. You might want to change the speeds and stuff of different tubes and stuff like that, so they're in as options here. We add it then with a z index to the child, and I'm just double checking whether we've got this z index for a tube because I couldn't remember. Yes, we have. It's in here like this. We then add it to the tube array, and then we return that tube. So that should be fairly straightforward as well. The point that's important is here. Every time a tube gets set to inactive after it's gone across the screen, we can reuse it instead of just generating yet another sprite. It's just a little bit more efficient. So now we've got to do is a little bit of game logic. So we want to be able to stop the tubes in their tracks for a start. So what I'm going to do is I'm just going to go below stop clouds here and add in a function to stop the tubes. And this function here simply stops all actions on the tubes. Remember, we don't call the stop because the stop itself also sets the tube as inactive. We here just want them to stop moving across the screen, to freeze a little bit. And then the other thing we want to be able to add then is the functionality to actually clear them, or at least give the impression they're being cleared off the screen. They're just being moved to minus 1000. So we go through the whole array and then call stop like this. So we want to call the stop tubes inside stop game. So we'll do this here, and we'll just go this dot stop tubes. And then it's in the re-enable after game over that we actually want to clear the tubes. So we'll just do this dot clear tubes like so. And now the tubes will be cleared off the screen when we re-enable after game over. Now one thing that we need to do down here is we've got our spawner tube, but what we need to do actually is inside the spawn upper or lower or tube pair, we actually need to say that we want to spawn these tubes. So inside the pair, what we do is we want to spawn one upper and one lower using the top y and bottom y that we've declared. In the case of the upper or lower, we want to spawn a tube with our isUpper here, set here, and the y position we've declared. And that's all we need to do now, hopefully, to add tubes to the screen. So if I just refresh the browser, and now you can see that we've got, as the game progresses on, tubes actually scrolling across the screen. Now if I crash into the floor, you can see they pause and they should disappear hopefully now, and they have indeed, and we're ready to start again. And you can see it's found, you sort of found reusable tube on the right hand side there in the console. So it's reused a couple of tubes that already produced. And now we've got some nice tubes appearing on the screen. We haven't got the collision detection in yet, so we can just simply fly straight into them. But you can see now that the game is nicely taking shape. It took a few videos to prepare this, but now the effect is quite nice with the tubes. Okay then, that's it then for this video. The next video we'll start putting tube collisions into place. Thanks very much for watching. Any questions or comments, feel free to add them down in the appropriate section. See you in the next one.